Hi, in today's video we'll explore fundamental concepts needed to compute integrals in various problems. I'll introduce you to basic formulas as well as to integral calculation methods, integration by parts and by substitution. Let's begin by introducing the basic formula for integrals. The operation appears to work inversely to derivatives, thus the derivative of a result should be equal to the integrated function. After simplifying it, this is turned out to be accurate. With our formula established, let's dive into our first example. On the side, I will attempt to find a function whose derivative is equal to x cubed. The derivative of x to the power of 4 is close, but there is that 4 preceding x to the cube, so we should multiply our function by a fraction of 1 to 1 of 4, and that settles it. However, let's pause for a moment. You may recall from derivatives that the derivative of a constant number is equal to 0. Therefore, our result could be also be x to the power of 4 divided by 4 plus 2 plus 5 or plus 79. In summary, it could be a number added to that function. It could be any number, so we'll denote it as a c and add it to our result and also to our formula. In the next example, we'll solve a similar but more advanced problem. The first thing we do is change the roots to the powers to make it easier to use our formula. Then, thanks to additivity, we can separate this integral as sum of two integrals. And we can see that the first one is multiplied by 4. We can put this 4 outside the integral, and that's to the thing called homogeneity, and that's all. Now we use our formula. We have c1 from first integral and c2 from the second one. We can sum them up and write only c. In the third example, we'll need to employ different formulas than the one we've been using before. Specifically, it happens when we integrate a trigonometric function. So let's separate those integrals and we can use these formulas. So the integral of cosinus is sinus and integral of sinus is minus cosinus. That's all. Let's proceed to the next example. Now we have to integrate the product of functions. We can simply separate them. This approach only works with real numbers, not functions. Therefore, we must utilize the formula for integration by parts. Let's designate f as x and the derivative of function g as cosinus x. Then we also need to determine the derivative of f and the integral of g prime. The only thing left is to substitute these functions into the formula. Now let's discuss the last method I will show you, integrals by substitution. We have an example like this one. It's also a product of two functions, and as you try using integration by parts, you'll see that it doesn't work there. So what we do is substitute t for x squared. When we take the derivative, it turns out that it matches perfectly, because from x times dx, we can substitute dt divided by 2. And now we are left with an easy integral where we have the parameter t, not x. It's easy to calculate it by formula, which you can find in description of this video, and at the end we came back to using x. And that's all for today's video. To see more videos about integrals and other math stuff, I advise you to go to see other videos on my channel. Thanks for watching. Bye.